Hello and welcome to today's daily Leetcode challenge. Today we'll be solving a question. As I solve it, I'll be going through my thought process, and then at the end of the video, I'll compare my solution to the solution of others on Leetcode. With that, let's begin question 1282. Group the people given the group size they belong to. So, there are n people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n minus 1. You're given an integer array group sizes where group sizes I is the size of the group that person I is in. For example, if group size of index 1 is equal to 3, then person 1, person with the ID 1, must be in group size of 3. So basically the group sizes array is a mapping from person ID or person's ID to the size of the group that they belong to. Return a list of groups such that each person I is in a group of the size group sizes. So return a list of groups where that list of groups contains elements that group together people. Okay, each person should appear in exactly one group, and every person must be in a group. If there's multiple answers, return any of them. It is guaranteed that there will be at least one valid solution for the given input. Okay, so a bit wordy, but it boils down to us being given a map. This map is actually just a list of person ID, or let's just say person to the group size that they're in. And so the input array looks something along the lines of this, where we have person index 0 belongs in a group size of 3, person 1 belongs in a group size of 3, person 2 to 3, person 3 to 3, person 4 to 3, person 5 to 1, person 6 to 3. And as the output, we see a list where each element is a list of in itself describing the group. So here we see the group of 1, person ID 1. Here we see 3 and 3. Okay, and the explanation, I guess pretty simple. Constraints, nothing significant there, with the exception that the groups are, there's not that many people, and the group sizes are also, less than or equal to n. Okay, so how do we go about this? It is pretty clear to me that I have to start splitting these people up into groups. The question is, what is the easiest way to do that? Well, my initial thought is, what if I just create the groups that are possible? So the group sizes that are possible. For me, this would be a group size of 1 and a group size of 3. And then as I'm iterating over the input group sizes array, I populate this, I create these sort of temporary subgroups. And that seems like it would run almost in ON. I would run through it initially once to get all the group sizes, and maybe even at that point already split up which people will belong to which group. And then upon another iteration over the group sizes rather than the people, I will separate those people that belong to group size 3 into those groups of 3. So with that, let's begin the implementation. This is, I believe, is just pretty simple. Let's stay very explicit with our variable naming. I'm going to initially have a default dictionary called group size to people dictionary. This is going to be a default dictionary where the default element is a list. And then for PID, person ID, and group size in enumerate group sizes. I'm going to say group sizes. Group size is going to be the key. And I'm going to append the PID. If I was to print this right now, I should see that I have a dictionary where the keys are the group sizes, so 1 and 3, 1 and 3, and the value is a list of people that belong to that group. From this point on, we will now be iterating over the people in the different group sizes and splitting them up into their groups. So what is this going to look like? We have a result, which is just the output array. And let's say for group size and PIDs, people's IDs in items. Items is a way to destructure the key value pairs into key and the value. I'm going to say that while length of PIDs is greater or equal to the group size, meaning that, let's say PIDs is right now at 6, but I know that the group size is 3. I'm going to say res append PIDs from 0 to the group size. And then I'm going to rewrite what PIDs is equal to. PIDs is equal to group size and on. What that does is I append the first group of 3 people to my result, and then I rewrite what PIDs is into group size and on. So starting at starting at group size 3 and on. And as a return, I should be able to just return the group, the result. And a quick error. Collections default has no items. Oops. Sweet, very, very simple. Let's see if this works for everything. Otherwise, I think it's very clean and very some solutions. So there are faster ones. Let's compare. Let's see how and where they were able to increase. So they have a hash map, same as what we did. Enumerate a one-to-one res for V, which is probably just the group size, right? Let's see. Enumerate and the group size. Yes, so V here is the group size. Terrible naming. Array is the array of people. For temp, which is probably just going to be, yes, res append temp. For I in R, if. So what they're doing here is a bit different. What they're doing here is they're never rewriting the value of this R. So they're iterating through every PID in R, and they're saying that if len of temp is less than V, then temp append. But in which case do they? 1 second. For every PID in PIDs, if length of temp is less than V, which it will be, for example, let's say that V is 3. I'm going to say temp append I. And then if length of temp is equal to V, I'm going to rewrite. Oh, okay. Got it. I know how to fix this. Let's not rewrite our PIDs list. What they're proposing is temp is equal to this, and for PID in range, nope, not PID, just PIDs, I'm going to say that if len temp is less than group size, I'm going to say temp append PID. And then once we have this equal to group sizes, we're going to say res append temp, and temp is equal to a blank array. This way, we're still collecting all of the different groups, but we're not rewriting PIDs, which should be a bit faster. The rewrite operation for a list is slightly difficult. However, I see that this did not significantly increase our speed. So although this solution is technically faster, I still like this one more just because it's a bit cleaner, but whatever works for you. Yeah, and with that, this was an easy question today. So thanks for watching. Please like and subscribe, and I will see you later. Bye.